This is the introduction to section 10.1, part 1, where in section 10.1 we're going to start talking about the areas of parallelograms and the areas of triangles. And in here, again, you can find the area of any parallelogram or any triangle as long as you know its base and its height. So, let's first talk about here the area of a rectangle and a parallelogram first. Okay, the area of a rectangle is the product of its base and height. So as you're looking at this picture here, we have a rectangle, four-sided figure with four 90-degree angles. And you'll notice you have the base and you have the height. If you multiply the base times the height, it gives you the area of that rectangle. Now, what does that mean, the area of the rectangle? Essentially, how many 1 by 1 squares can we put into this box? That's essentially how much area that is. Okay, so as we look at the area of the parallelogram, you'll notice the formulas are the same. The only difference between a rectangle and a parallelogram is now the fact that your bases could be different and your heights could be different on how you look at it. So again, the area of the parallelogram is product of the base and its corresponding height. So this is the key word, the corresponding height with the base. You'll notice this is the base right here, and the corresponding height is this dotted line that's perpendicular to one of the sides. And if you remember, if we draw a line from a vertex to the line opposite and it's perpendicular, that's what we call the altitude. Well, here, the base of a parallelogram can be any one of its sides. So in this example down here, you'll notice as the way that this is sitting, this is the base, and they also could use this as the base. Well, the corresponding altitude, remember, we said that if a line goes from a vertex to the opposite side and it's perpendicular, that's an altitude. Okay, that is considered the height. So the length of the altitude is considered the height. So depending on what base you're looking at, your heights could be different. For example, I could draw this right here, just like this, like so. Okay, I've taken this one right here and I have flipped it up on its side. Okay, so now this would be the base and this would be the height, depending on how you're looking at it. Alright, now they're going to have you do some different things with parallelograms as well as we look at these. Okay, alright, so we know that the area of a parallelogram, area of a rectangle is base times height. So let's take a look at some examples. What's the area of this parallelogram? As you look at this parallelogram, okay, and you got to figure out what base and what height you want to use. I'm going to use this as my base, which means that the 4 is the height. If I use the 4.5 as the base, I don't have the height for the 4.5. So it doesn't correspond with that. So that's why I use the 5 and the 4. So in this case, the area is 5 inches times 4 inches. And yes, your units are going to matter here, so you are going to have to pay attention to units. So 5 times 4 is 20, and an inch times an inch is an inch squared. So the area of that parallelogram is 20 inches squared. Okay, if you look over here at this example, example B, I'm going to have you hit pause. Go ahead and see if you can try and figure it out on your own and come up with your own answer. Okay, now that you've hit pause, let's take a look here. The area, we got to figure out which one are we going to use as our base and our height. Well, I know that this is the height, 3.5, and this is the base that corresponds with that height. So in this case, I'm going to take 2 centimeters times 3.5 centimeters, and 2 times 3.5 is 7. Centimeter times a centimeter is a centimeter squared. So the area here is 7 centimeters squared. Okay, here they want you to find the missing dimension. So they want to know, what is the length of DE to the nearest tenth? Well, DE happens to be a missing height. So we know that the area of a parallelogram is base times height. Well, we don't know the area, and we know that the base is 9.4 inches, and we also don't know the height. Well, wait a second here. We've got two variables. We can't solve that equation. So we're going to have to find another way to solve it. So, if you look on the other side and you use this as the base, where you say the area is base times height, the area we don't know, the base is 13, the height that corresponds to 13 is this height right up here. Remember, this right here is the base, this is the height. If I use the bottom base, that's the height. And these two heights are not always going to be the same, ever, as a matter of fact. So I know that the area of the parallelogram is 13 times 9. Well, 13 times 9 in this case is 117, and my units would be inches squared. So I know the area of the parallelogram is 117 inches squared. Well, now I'm going to substitute this in. So this is 117 inches squared equals 9.4 inches times the height. Well, now I only have one variable. So I can go ahead and solve for the variable, divide by 9.4 inches. And 117 divided by 9.4, if I round to the nearest tenth, I end up with 12.4. And I have 2 inches up top, 1 inch on the bottom, so those are going to cancel out, and I'm left with an inch. So 12.4 inches is the height. You will see a couple of problems like these on some homework. Okay, so what I want you to do, I've already drawn this picture for you. See if you can figure out this answer by the time you come to class tomorrow, and we'll talk about that at the beginning of class. Okay, the next item that we're going to talk about is the area of a triangle. Okay, and you'll notice there's a couple of different things here. It says here you can rotate a triangle about the midpoint of a side to form a parallelogram. Now, if you take this case, you'll notice these two triangles here are exactly the same, and you'll notice that we have a parallelogram. Well, it's the same thing if you have a rectangle. If you have a rectangle and you take the diagonal, these are two triangles that are exactly the same. So essentially, the area of a triangle is half the area of a parallelogram or a rectangle, which the area of a parallelogram and rectangle is base times height. So, as we look now at the area of a triangle, it says the area of a triangle is half the product of its base and the corresponding height. Now, they write it as 1/2 base times height. I would like you to put it in your notes as base times height divided by 2. It's the same thing. Sometimes it's easier for people to see it this way. Okay? All right, so now we're going to look at finding the area. So it says you want to make a triangular sail like the one at the right. In this case, the one below. How many square feet of material do you need? Okay, so they give you in this case right here is the base and right here is the height. The trouble is that they're not all in the same units. And it wants how many square feet? That's not 12.2 and that's not 13.4. I know that there are 12 inches in 1 foot. So if there's 2 inches in that are left over, if I take 2 divided by 12, I get I take 2 divided by 12, I get 1/6, which if I take 1 divided by 6 and I round that, you get 0.2. So this is really 12.2 feet. 13.4, again, 4 inches out of 12, that's 1 divided by 3, or in this case, 13.3 feet. That's the base, that's the height. I want to find the area. So the area is 12.2 feet times 13.3 feet divided by 2. Well, when I calculate 12.2 times 13.3, I get 162.26, and that's feet times feet is feet squared. And if I take the 162.26 divided by 2, rounded to the nearest tenth, that's what we'll do everything in. In this case, the area of the triangle, or of the sail, is 81.1 feet squared. Now again, as you look, there's 12 inches to each foot. Okay, so if there's 12 inches to each foot, I take 2 inches divided by 12 inches. That's 1/6, which in this case is 0.2. We rounded it. And then I take 4 inches divided by 12 inches. That gives me 1/3, which again I'm rounding, which is 0.3. So roughly 81.1 feet squared. Okay, now, in this case, what's the area of the triangle? As we look at the triangle here, what's the area of it? We got area is base times height, and you'll notice we've got some different units here. So I'm going to convert these all to inches. Instead of 1 foot, I'm going to say that's 12 inches. 1 feet, 1 inch, there's 12 feet in an inch, or 12 inches in a foot. So that's 12 inches plus 1, that makes this 13 inches. So, in this case, the area, the base is 12 inches. The height is 5 inches. And we're going to divide that by 2. So this is now 60 inches squared divided by 2, which in this case, the area of this triangle is 30 square inches. Okay, 30 square inches. Okay, last one to take a look at here now, and that is find the area of the figure here. And this time we've taken 2 shapes and put them together. So we've got to do 2 things. We're going to find the area of the triangle, we're going to find the area of the rectangle, and then we're just going to add them together. So in this case it's not really a rectangle, it's more of a square. So I know if it's a square, that's 6, and that's 6, and that's 6. So the area of the triangle is base times height divided by 2, which in this case the base of the triangle is 6. The height of the triangle is 8, and I'm going to divide that by 2. So this is 48 divided by 2, which is 24 inches squared. That's the area of the triangle. Area of the square is 6 inches times 6 inches, which is base times height, which is 36 inches squared. So now, in order to find the area of the whole thing, I take these 2 and I add them together. So 36 and 24 is equal to 60 inches squared. So the area of that whole figure is 60 inches. So you find the area of one, find the area of the other, and add them together to get your total. Okay, this concludes sections 10.1, part 1. Don't forget to complete your WSQ.